Hey guys, NJ here, and today we're having a look at the Team Black Sheep Crossfire micro bundle. Now this at its heart is a long range system, and long range systems have been around for a while. I mean, there are things like the Easy UHF, there's the Dragon Link RC, and although it's something that I've always wanted to move over to, it has had its problems, and certainly in terms of cost it was quite an expensive thing to do. Some of those modules are also quite big and often required external power. So this guy has come along. This is the micro Crossfire transmitter, and this actually fits straight into the module bay, so it's all been considerably miniaturized. It doesn't have the same power output as its bigger brother. It will do 25 milliwatts, and it will also do 100 milliwatts, but believe you me, that is more than enough for the kind of things that we do with our quadcopters, and certainly will exceed the range of our standard 2.4 gigahertz receiver systems. Now, one of the reasons these long-range systems work so well is that we're operating at a much longer wavelength and a lower frequency, certainly in the UK here, of 868 megahertz as opposed to 2.4 gigahertz, which is what we're currently working with, certainly on things like the FR Sky Tyrannus. You can see this reflected in the antenna size. So if we actually have a look at the receiver here, you can see that this, which is a dipole antenna, which you would normally have out like this in a nice straight line, you can see the length of it. It's pretty damn long, and if you compare that to something like this XSR by FreeSky, which is on the 2.4, and this is receiving a quarter wave, I think the XM Plus will be fifth wave, you can see the difference in antenna length, and these longer frequencies, these longer waves do a much better job at bending round buildings and penetrating through trees, etc, etc. So as well as having the range advantage, they're also good for flying around objects and maintain a really solid link where otherwise the 2.4 system has been known to fall over. So that's one of the advantages. As I said, a disadvantage is when it comes to mounting the antenna in your quad. You see, we've got a lot of antenna to mount here that we want to make sure is away from any carbon if possible, and also away from the props. And you know, when it comes to antennas, that can be a little bit fiddly to try and do. The Crossfire Micro, unlike its bigger brother, doesn't have a display on the back to change any of the individual options. So the way that's dealt with now is through a Lua script, which you have to put onto your Tyrannus SD card in a folder so that you can access it and then get into the settings of not only the transmitter but also the receiver. And having set this up and done it, I can say it's very straightforward process, and we will go through that. You get this nice dipole antenna which will come with it, which is SMA terminated. That goes on there like that, and the module simply plugs in to your Tyrannus at the back. So I've got my Tyrannus here, which you can just about see. There is the module bay door off, and this guy quite simply plugs in, and that is us done. We've got a bind button here, which is kind of like an all-in-one function button, but when it comes to binding, I prefer to do it using the Lua script, so I will take you through that process. One thing I also didn't like about the old long-range systems was the size of the receivers. Often they were pretty big. It's bad enough having to deal with working with a much longer antenna and where to place that, but then you've also got limited space inside most of our quadcopters to be able to fit a large receiver. So TBS have done a great job in making a micro receiver. Again, it's only a few grams, and I'd say it's somewhere between the XSR and the XM Plus. Certainly in terms of dimensions, it's kind of a mash of the two, quite long and thin, but very easy to accommodate something like this. Certainly in a 5-inch, 4-inch, I wouldn't think that's a problem. Maybe a bit of a struggle in the 3-inch because of the length of it, but this is certainly much easier to deal with. Now, as well as getting 2 of these in the pack when you buy the receiver, which are IPEX terminated, you can also buy as an accessory this guy. Now this is their Immortal antenna, also by TBS, and I think this has spring steel in it, so it's really great at holding its position, and it's kind of arranged in this nice dipole T configuration. Now, where you mount something like this is the subject of great debate. What I did with my Diatone GT2 when I tested this out was actually to mount the Immortal antenna like this. Now, the whole point of doing it like this, just with any antenna, is to try and get it out in clean air and away from the carbon. And because of this spring steel, there's really no danger of that going into the props. And I've also heard that these have survived lots of prop strikes from other people who've had a go with the Immortal antenna. So it's nice that they're bringing out accessories like this that can work with our quadcopter. Now, a word on polarization. There is a couple of ways to do this. Now, if we look at our transmitting antenna, which also looks like this, which is a dipole, if this is the direction that we are flying away from ourselves, then the strongest signal we will get, or the strongest reception the quadcopter will get, is when this is in polarization with this antenna. By the same rules, the weakest reception we'll get, just as with any dipole antenna, is when the quadcopter has the antennas facing like this, pointing straight towards the receiving antenna. At this point it's out of polarization and we're going to have a reduction in reception at the quadcopter. So there is a way to actually make this more robust, but there is kind of a little bit of a penalty here. So what you can do, and believe it or not, this was something that I spoke to Trappy himself about. My understanding of a dipole like this is that you needed it to get the best reception in a straight line parallel like this, as opposed to a twin antenna diversity setup where you have the option of running these two at 90 degrees. But having done a bit of reading on the subject as well, it is perfectly acceptable to take a dipole antenna and in fact run it at 90 degrees like this, something that we would only think is really a diversity thing. You can do this with a standard dipole antenna as well. And what this allows us to do, just as with diversity at 90 degrees, is that no matter what orientation the quad moves into, one of them will come into phase. So as this one starts, say we turn and twist our quad, this one's now pointing at the transmitting antenna and the signal starts to drop. This one has come into phase with the antenna. So as the quad rotates through all of its axis, one of these antennas will always come into phase. However, the downside of this obviously is that we sacrifice a bit of range having it in this array. So basically this, facing this in the correct polarization, will have the greatest range. This antenna facing this direction will have probably the weakest range. We're really kind of being basic about this, but this is kind of how to look at it. This will have the weaker range, and then this guy will sit right in the middle of the two. It won't be quite as good as the antenna in this polarization, but it won't be as weak as this antenna in this polarization. So this is a nice halfway house. So for me personally, on the next quad I build and this receiver's going into, I will go like this. Most likely with this straight up and this one coming out the back. I think that will probably be the most sensible mounting method. So in terms of wiring this guy up, it really is very straightforward, and you can get this to work quite happily just running the standard S-Bus protocol. The way you will do that we will go into shortly over on the transmitter, but what you have here from the left pin to the right, we have the ground on the top pin here. We have 5 volts in. The next one we have down is channel 1, followed by channel 2, channel 3 and channel 4. And the way you configure what those channels will do is done using the Lua script in the Tyrannus. So what you'll need to do is wire this up to a spare UART. In this case I've got it over on UART 1 of this BetaFlight board. So I have the ground on the left here, I have the 5 volts, I have the, let me see, this is the receive pin as channel 1, because this will be transmitting to channel 1, so the receive pin on the board, and channel 2 will be receiving telemetry information, so that will come from the transmit of the UART to the receiver. So that's how we wire it up. If you wanted to wire this up for S-Bus, you would just follow a standard S-Bus wiring just as you would your FrSky receiver, but we are going to be doing this using the Crossfire protocol with sending and receiving telemetry. So here's what we're going to do. Because this BetaFlight board has a 5 volt regulator on board, I'm just going to power this via USB. That will supply power to the receiver like so. And you can see here we have a solid red light and everything is working there on the micro receiver. The next thing we're going to do is to press this button here, which is our bind button, and it is one short press to do so. and now we have a flashing green, which means that it is ready to receive a binding command from the transmitter. Now normally I would suggest separating your receiver and your transmitter a lot more than this, but because I haven't really got the space to do this on video and I'm being lazy and not rigging up another camera, I'm going to do it so that they're both in shot. One thing you'll need to do before starting all of this is to make sure you go over to OpenTX and you download the latest version 2.2 for your Taranis. This will include the Crossfire Lua script. You'll see that in the SD card bundle that you download, and that's a really important thing so that we can get into and operate our micro TX and micro receiver. So we have this flashing in bind mode and powered, that's all good. The next thing we need to do is turn off the internal module of the Taranis, and the way we do that is to go into the menu, make sure we have the correct model selected. We are going to page across, and then I'm going to go straight to the bottom of the menu by pressing the plus button, so round robins. And you can see here, if we move up, that internal RF, which is the one in here, and its mode, which is currently in D16 mode because it was bound to an FrSky receiver. So we're going to press enter on that, and we're going to move it until it says off and press enter. That's turned off the internal receiver. We are now going to go down to external RF, which directly powers our module at the back, and then we are going to select that and move to CRSF, which is the Crossfire protocol. So we're going to press enter on that, and that will now apply power to the Crossfire module, and if we turn that round you can see we now have a glowing yellow logo on the back of the function bind button. So the next step will now be to hold down the menu button to go to the sub menu. We're going to page across once, and we're going to move down to that SD card folder rather, which is the Crossfire folder. We're going to enter that. We're going to move down and we're going to execute the Crossfire Lure, and the way we do that is to hold down on it and click execute, and then at the minute, because we're not bound, it's going to show us the options for the internal TX. So we're going to press enter on that, and then you can see we have some options come up. Now at the minute I have these options set up, so I have the region set to open, which I will leave, max power 25 milliwatts, dynamic power I have off. The dynamic power will allow this to scale the voltage depending on the quality of the link it sees. It's up to you whether you want that on or off. Because I'm in the UK, I need to use 868 megahertz. You can change that to 900 megahertz if you're in the US, and operation mode you leave as normal. So with all that set, I'm going to go to binding. I'm going to hit, let me make sure this is in shot, I'm going to hit enter on that, and then it will start looking for the receiver, and you can see it's found the receiver and now asked if I want to update it. So I'm going to press enter, and it should start the updating process. And you'll now see it saying RX is loading, don't interrupt. So it's basically sending that information over, and there we go, it's all done. So the way we know that this is all working, we've now got a solid green light on the receiver. If we flip this guy over, you will see I have a solid green light on the back. Okay, so with all that bound up and linked and working, we can now exit this Lure menu, and you'll see we've gone back one. Now TBS Crossfire Micro RX has turned up, which is great news. We know that's all working. If we enter that, we can look at the settings of the receiver. So if we scroll down from here, we've got it in 8-channel mode. If we go down from here, we can actually set, if you want to use S-Bus, there's a couple of things we want to do. Output 1 by default will be set to PPM, so we're going to press enter, we'll move that across to S-Bus, or you can have non-inverted S-Bus, which is a great feature. And then you can also set your S-Bus rate, instead of the standard 50 Hz, you can run it up to 150 Hz, so even faster. So that's definitely worth considering trying out if you want to go that route. Myself, I'm going to be using the Crossfire protocol, which this is on BetaFlight 3.2 and it works flawlessly, so I'm going to be using that. The way we do that is to press enter, and we're going to move that to Crossfire transmit for output 1, which is the way I've got it wired up on the board, and then channel 2 will automatically assign as the receive Crossfire channel, I think. Yes, it has. So that's that done. And then if we get the channel map, if we go down to channel 12, we can change that guy to LQ, which is link quality, and this will act as our RSSI for the OSD. So if you go into the receiver tab of BetaFlight, you can then change, you can set the RSSI as 12 up in the top right hand corner and save it, and then this will give you a link quality down that channel, which will display up in our OSD in you know, wherever you've placed your RSSI, so that we know exactly how strong our link is the whole time we're flying. Heads up, it's pretty much always damn good. So here in BetaFlight there are a few things we need to do. Because I wired my receiver to UART1, I need to go to UART1 in the port section and enable serial RX, then save and reboot. Then over in the configuration tab, we're going to scroll down. We're going to make sure that serial based receiver is selected, just as you would with SBus, and then the serial receiver provider this time is Crossfire, labeled CRSF. With that done, save and reboot, and then you can go across to the receiver tab where you'll see everything is moving and working the way it should. Now in the Lua script of the micro receiver, we set the LQ or link quality to channel 12. Now that equates to auxiliary 8, which you can see here is almost full, just twitching a little bit. Remember, this is channel 8, auxiliary 8 is channel 12, because you've got the 8 here plus you've got the 4 at the beginning, so you've got 1, 2, 3, 4 plus the 8 auxiliaries gives you channel 12. So that is indeed giving us the link quality, which is going to act as our RSSI down auxiliary 8. So we need to set that over in the RSSI bit up here to channel 12, which we have. We save that, and then when we go over to the OSD menu, when you have RSSI value enabled up here in your OSD, this won't display in real time here, but in your OSD you'll notice that that figure is now active and giving us a representation of our link quality or RSSI in flight. And with that all wired up and working now, the next thing to do is to press the menu button once. We're going to slightly longer press the page button to go back to page 14, and one more time to go to the telemetry screen, and then we can now scroll down to discover new sensors, and if this is all working right, we should get, there we go, all the sensors turn up. So we have telemetry working. That's brilliant. Now one last thing I just want to talk about is the latency, and it's definitely worth a mention. It's something that the Crossfire system also brings to the table. Lower latency. Now is this something that you'll notice? Some people are claiming it's a bigger jump over SBus as SBus was over PPM. In my experience, I'll say this. Look, it definitely is a noticeable change in latency, and it was something that I wasn't even thinking about when I went out for my first test flight. I just wanted to really just start having a go at some longer range stuff, and the minute I started moving the sticks, it just came straight to the forefront of my mind, and I immediately thought, wow, I've really noticed the latency on there. And there are other people out there very credible who can give testament to this. I'll put a link in the description to Snake FPV's blind test, and you can see how obvious it is to him. And then there's also the testament of people like Thomas Bitmarter, who's, you know, he's pretty much winning everything out there. If you want someone with cat-like reactions that would really be able to notice this stuff, it's him. And he seemed to think it was a pretty instantaneous thing when he noticed how much better the latency was running this setup. So in conclusion, am I sticking long range system? Am I swapping over all my receivers? I am. I'm so impressed with not only the latency, the link quality, the functionality with the Lua script. I mean, the only downside is this. Look, the receivers are expensive. At £56 a receiver compared to an FR Sky's, what, £12 for an XSR over here in the UK. That does make you think twice when you've got a lot of quads in your collection, but I'm really going to struggle to go backwards from having this now it's installed. I do hear, however, that there is talks of these receivers coming down in price fairly soon, so it's definitely worth keeping an eye out for. I think long range systems have arrived. Well done, TBS.